On this episode of This Week in Space, we're talking with Rob Manning, the chief engineer and grand wizard of tech at NASA's Jet Propulsion Laboratory. We'll be discussing Mars rovers, orbiting robots, and all kinds of other cool space tech. Stay with us.
Podcasts you love.
From people you trust.
This is Twit.
This is This Week in Space, episode number 81, recorded on September 29th, 2023. The Carroll Shelby of Mars, Rob Manning, chief engineer at NASA's Jet Propulsion Laboratory. This episode of This Week in Space is brought to you by Melissa. More than 10,000 clients worldwide rely on Melissa for full spectrum data quality and ID verification software. Make sure your customer contact data is up to date. Get started today with 1,000 records clean for free at melissa.com/twit. And by our friends at IT Pro TV, now ACI Learning. IT skills are outdated in about 18 months, so launch or advance your career today with quality, affordable, entertaining training. Individuals use code TWIT30 for 30% off a standard or premium individual IT Pro membership at go.acilearning.com/twit. Hello and welcome to another episode of This Week in Space, the Carroll Shelby of Mars edition. I'm here today with the indescient Tariq Malik, editor-in-chief of Space.com. Hello, Mr. Malik.
Hello, Rod. I don't even know how to spell into whatever that word was.
Indescient, and do you know what it means?
No, I don't. But,
would you like to know?
Sure, yes, please. So,
it means a seed pod or fruit that is not splitting open to release seeds when ripe.
Wow.
I don't know what that implies, but we'll move right along.
I guess
we're
that's
joined
me.
today. I have the great privilege today to be joined by Rob Manning. Rob's the chief engineer and has been the chief engineer of every wheeled machine that ever landed on Mars. Started his career, I believe, on the Voyager program and about a dozen other missions. Is now the chief engineer for all of NASA's Jet Propulsion Laboratory, which is a very big job, which he'll tell us about. And he's a peach of a guy to boot. Hello, Rob. Thanks for coming.
Rod and Tariq, thank you so much for inviting me to come. It's a real honor and privilege to talk to you, my friends. It's great. This is fun.
No.
Great.
The honor is all ours. But before we begin, I will tarnish the honor by reading a new space joke from listener Kogoman.
Kogoman.
Didn't sign his name. He just said Kogoman. Are you ready?
Yes, I'm ready.
Ready.
Hey, Tariq.
Yes, Rod.
Do you know why it's been so hard to find the 10th planet?
No, tell me.
Because it's inhabited by goths and they painted it black. Okay. Well, we'll move right along. Rob, did you bring a joke today by chance?
I should have. I did not. I wouldn't be able to compete with that. Yeah. My jokes tend to be less gothic in nature.
Less emo. Well, as always, we invite you to...
more baroque, right? Instead of...
All right, you guys. Tone it down here. Don't forget to do us a solid. Make sure to like, subscribe, and all that podcast stuff because we're free for you. Let's go to some headlines. Hey, Tariq.
Yes, right.
Where did that? We have samples back from Bennu. This is very cool. Actually, this is a Tariq and Rob thing because you were both part of that mission.
Yeah, it was really exciting. So, we just recently had folks from OSIRIS-REx come on the show and tell us all what we could expect. And, aside from one kind of weird parachute thing, everything seems like it went just fine out in, Dugway Proving Grounds in Utah. The sample return capsule, SRC, I think is the acronym there, plunged through the atmosphere, dropped its parachute a bit higher. It deployed than they expected, but it was fine. It landed out there right by a road, which is just crazy aiming by NASA. Even though they arrived in helicopters, but they got it back. It's actually within a couple of days, it made its way from Utah to the receiving laboratory at the Johnson Space Center. They cracked open the lid and they found immediately stuff all over the capsule and container. So it seems like all of those hopes that they're overflowing and brimming with asteroid samples, the most ever.
Well, it was four times what they had estimated, right?
Exactly.
Which is incredible.
And man, I just it was amazing to see. You know, we have a bit of a, I don't know if it's an old wives' tale or a superstition at space.com, but we don't make jokes about those like reentries at all, because the one time that someone said something errant was during Genesis, and of course that Genesis capsule like, you know, crashed when it did not deploy its parachute. And Dante Loretta, the principal investigator, said that he was just trying to hold it together in the helicopter, listening to the milestones as it was coming back, because they weren't getting that visual confirmation of the drogue chute, which is like one of the big steps before the main parachute comes out. And then of course the parachute did deploy at something like 30,000 feet instead of like the 5,000 or 6,000 feet that they were expecting. And it was just because it's set, you know, to speed parameters. And that's what the onboard computer said was the right time to do, as I understand it. I mean, I'm sure they're going to go through it all with a fine tooth comb.
You might be able to ask our guest if you wish.
Yeah, that's right, Rob. You can tell us, right?
I am holding back. I have all my friends. By the way, I want to congratulate the OSIRIS-REx team and the science team. This is such wonderful news. This science we're going to get back from this is going to be amazing. Here we have pristine, clean samples taken from an asteroid, an interesting asteroid, no less. This cobbled together of tiny particles and rocks just blew our minds when we touched down. Anyway, it's a real privilege, and so I've resisted calling my friends at Lockheed and at Goddard, who's like, "Hey, can you tell me the story about the parachute? What's going on there?" You know, that was kind of interesting. That was kind of freaking me out there for a bit. I was watching, also holding my breath, but you know, in some sense, you know, some reason we put margin in our designs that sometimes just pays off and it works. And it did in this case. And I'm just so excited. So I have not heard the details of what happened with the details of the entry descent land, or the entry descent landing for part of the system. But I will be patient and learn later when they're ready to do the math and figure it out. Because sometimes it's so easy to get it wrong your first time looking through the data. I've been there. You just have to keep staring before you. It's easy to come up with, you know, oh, I think it says, oops, that wasn't it. Oh, no, it's not that. Okay, never mind. And so people get confused. I remember when Spirit landed, people were saying, oh, it almost didn't work. It's just things just barely made it. And I go, I wasn't aware of that. Oh, you heard data from the day of the landing, which we thought was something bad. It turned out it wasn't so bad, but you know, it's one of these things that's easy, the fog of war kind of thing. But anyway, it's wonderful. The science is there. That wonderful landing, nose down, book, balancing on its nose on this little tiny sand dune right next. And I think that road is actually an old railroad bed. There's no tracks on it, but it was at the far eastern end of the far eastern end of the landing ellipse. But right there, perfect. Just grab it, you know. And it was wonderful. We're just so happy for everybody. And my old friend Tim Pricer doing the voice commentary. He was fantastic. And Sandy Freud, who is the project leader at Lockheed, they did a fantastic job. I just want to congratulate them. Yay.
Yeah, that's right. And Tim Pricer spoke actually after the landing and was talking about that whole moment about the parachute and how, you know, they're pretty sure the drogue came out one way or another because it's on top of the main parachute, and it has to come off so that the main parachute came out. Yeah, but one thing that you won't see in a normal landing, though, is ordnance folks go out and make sure there isn't any unexploded bombs around your asteroid sample so that the scientists can go and get it. They had to do that because this was a weapons testing ground for the Army.
Yeah. And the ordnance plus, you know, the same thing with Genesis and Stardust. We had to run people there with to make sure, because there's some batteries left inside. To operate these things, and kind of sense that those batteries could release and kind of release gases on harder impacts, but that wasn't at all the problem for OSIRIS. It was fantastic. Anyway, I'm thrilled. I do remember the Genesis landing. I have to tell a quick little story about the Genesis event back in 2004. I was on the failure review board, so I quickly flew out to the Dugway proving ground to just after Genesis. Parachute didn't open, and it just went tumbling and hit the ground. The principal scientist, the principal investigator, Don Burnett, was there in his white suit in this kind of a clean room. And I expected to be just like heartbroken. And he was there on the floor with little white envelopes in his clean room suit and a pile of dirt and broken silicon, because these are silicon wafers that captured this solar wind. And they're all just tiny little fragments. He was putting them in envelopes. I figured he's like, oh, be so sad. I looked at his face. It's like, he's smiling in ear to ear. I go, what's going on? Why are you smiling? I was like, well, I've got my science. I says, I thought, well, what if it's all broken and contaminated? I'll get it. And he did.
That's right.
I go, are you telling we never needed that darn parachute? All this time. In fact, not one, but multiple parachutes and a paraglider that a helicopter was supposed to grab out of the air at the same time. Like, oh man, that was a lot of work there, Don. Kind of wish you told us that. Anyway, we shouldn't have crashed it, but it was fun. It was fun to realize that, it turns out he got all the science he ever wanted from it, despite the fact that it got all dirty crashed on the floor. And if you ever seen the vehicle, so you see it looks like a flying saucer, right? Of course, it looks like a canonical flying saucer. And half of it is lit on edge, and half of it appears to be buried in the dirt. Well, if you go out there, you realize, no, that part of the spacecraft is only that thick. It's all been shattered and crushed, only leaving the top half, the top 3/4 of it sticking out of the ground. So it turns out it was because it's ceramic or not ceramic, but composite, and just at these impacts, it turns to kind of a glass like powder.
Well, it just goes to show you that both for those missions that you know how to build them at NASA. To get that
whether intentionally or not.
Yeah, at JPL, that's right.
And JPL, well, yeah. Well,
so, Tarek, would you mind if we actually did another story today?
Oh yeah, I'm sorry.
Is that okay with you?
Yeah, it's okay.
Okay. Hey, and from the sublime to the miserable, we have another government shutdown looming.
Yeah.
And besides closing the NASA theme parks, it's going to probably have a little bit of an impact on programs. So I'd like to hear from both you guys about this dreadful seeming inevitability.
Well, right before we started recording, actually, we got a note from NASA headquarters that went out to all reporters. And it's a statement from Administrator Bill Nelson where he was saying, and I quote, that they are deciding, he says, we are deciding what actions are needed in the event of and of course, this is his Democrat side coming out, a congressional Republican-led government shutdown. That's his quote. But he does say that NASA will maintain, to the people to protect life and property, operational missions like satellites, landers, rovers, and the space station and its crew. And that's their job. There's actually a 56-page document that NASA has and that they updated actually this month ahead of the potential for a shutdown. But it affects NASA just like every other part of the government. And as I'm sure, like Rob is aware, we mentioned it a little bit earlier at the start of the show, NASA's getting ready to launch another asteroid mission, the Psyche mission, which is supposed to launch now on October 12th. They have astronauts on the International Space Station with missions that have to be maintained there. The rovers, of course, with Perseverance and Curiosity on Mars. And so, that document, this furlough document, the government shutdown, it outlines who has to be on and who has to not be on. So people should look to not hear a lot on the public side from NASA if this shutdown does go into effect on October 1st, like we're expecting. That means that you won't hear press releases, you won't see great images or whatnot. For some of the really major things, like when Psyche does launch, there will be some sort of mechanism to track that. And we're hoping, of course, that there isn't a shutdown that goes that long. We want to report on NASA and get the information when we're not there at the site either. But I was on the horn with headquarters yesterday, and they were telling us that you can't send reporters to go see the Psyche launch because they won't let you through the gates physically to get there. So there's a lot of things that are going to be impacted for it. It's unclear exactly what the scope of that is, but stuff that is responsible for people's lives, like the space station, or hardware that has to be maintained, like the active missions that are either under construction or that are on the ground now. Those are going to be maintained. There's actually a report out of Florida, and I think we have a link to it, that the Kennedy Space Center itself is not going to close, and that a lot of the staff there will be actually paid because they have to protect the actual assets and the spaceflight assets that are there. It'll be very interesting, though, about how this is going to affect private spaceflight. There is at least one commercial flight, Virgin Galactic, on October 5th, launching out of Spaceport in New Mexico, and a bunch of passengers waiting to fly for that. I'm not certain how that, because of the FAA restrictions on who's working, will be able to get going. So very, very interesting to see how long this is going to last and what the impacts are going to be across the board, if not just the space agency.
So, Rob, how does this impact you guys, since you're run by Caltech?
Since we are in a contract with NASA as one of the national laboratories, and part of the FFRDC system, which is the federally funded research and development centers, which now it's the government has contracts with. Since we're on a Caltech contract, we can continue working at least for some number of weeks while this is going on. It just means that our key contacts at other NASA centers and NASA headquarters are not going to be accessible. And so there's a lot of things where decisions are required and cooperation needs to happen between the organizations that just will have to be put on hold until this is settled.
Well, that's a drag. All right. But just in time before this potential shutdown, NASA has revamped their website.
That's
Tarek,
right.
first impressions.
Well, I've only had, it just went live today, or maybe yesterday. I think it was today, because yesterday they said they were migrating over to the new one. And I've been through redesigns of websites like many times over the last 20 years, and they are never a fun thing. I don't know what to think yet. I'm not a fan right now of the new website itself, but it's very clearly aimed at mobile because of just the way that the layouts are. And that's a really good thing, because that's how most people are getting their news on the go these days as well. So, and it's obviously it's very image dependent, and that's one thing that NASA is awash in when it comes down to it, images and video. The circles creep me out a bit. You can see some of them there.
Wait, creep you out?
They're really strange.
Are you one of those people? There's a name for a phobia of holes.
Oh no, I don't. People? I don't have that. My wife does, but I do not have that.
Okay.
But I don't know. It's like they're not big enough to be functional, like for me as a web user, but they're too small. They're too small for me to understand what they're for yet. So I'm waiting to see, because there might be some tweaks over time. But I'm going to give it the benefit of the doubt. We've had some pretty bad launches at space.com in like the early 2000s and whatnot, where we had weird things that we had to update over time. I'm sure that they'll tweak it to where they get to. The one thing that I can say is I did not see the media resource page for all of the access numbers and and I've been trying to find it. And it's just possible that I haven't seen it yet, but I asked all my folks on the Twitter to help me out, because that's always really, really key when you don't have the numbers memorized, although most of them are on my phone these days. So,
okay, whenever you're done boasting. I have to say, though, it's been a long time coming. I remember,
he found it right there.
I remember
Come on, dude. Come on, dude. Mr. Tarek.
I was looking at it like literally for 10 minutes today,
It was like three clicks, dude. Like 3 clicks. Come on, man.
Okay, but regardless of anything else, what I got to give them kudos for, because I remember NASA talking about trying to put out a contract, because all the field centers had their own kind of versions of the NASA website, and there were probably 4. If you just go out looking for, not specifically for NASA headquarters, but NASA, I want to see NASA, you could find 4 or 5 different things that were all a little different. The imagery was stored differently. Things were delivered differently. The navigation was different, which was critical. So for them to finally begin wedding this together, whether we're completely down with the design and the navigational structure of it, it's a great first step, because at least now it'll be consistent across the brand, if you will. That said, Rob, JPL did a very nice job, if I may say so, because you probably won't, of redesigning their website, I believe, shortly after Pathfinder landed in the 90s. And we're always kind of at the head of the pack, in my opinion, my humble opinion. From there on out, you guys had a really strong web presence.
Oh, thank you very much. Part of it, I think, we are being in Southern California, it doesn't hurt, because we do have access to people who are part of, quote, the industry, the movie business and communication business who have a lot of talent and know how to do this kind of stuff. And as engineers, we are terrible at it, and we were doing it ourselves. I was personally creating my own JPL public websites for Mars Pathfinder, for example, and they looked at this stuff that we were doing like, you got to be kidding me. And so they were, so they looked, and okay, well, how would you do it? And I had no idea. They were good at it, and so having good people really counts. And we've had, by the way, many of those same people actually going over and to headquarters and helping out there too. I mean, this is not an easy thing to do. How do you communicate complicated ideas?
Yeah.
Because you got to balance between the inherent complexity of some of the stuff that we're trying to communicate with trying to keep ideas simple, straightforward, attractive, and a lot of people be curious at the same time. It's really hard to do. And I really respect people who do this and do this well, because it is hard. As you guys know, I mean, Space.com has the same problem.
I'm just reminiscing back in 2001 when I was a lowly intern and being mesmerized by being able to look at by being able to look at the panoramas from Pathfinder and seeing little Sojourner there at the rock, in the distance.
Yeah.
And then I could just kind of click and go through all of that stuff.
So you were one of those guys that crashed the JPL servers, or so legend has it.
We were. It was a fun time.
We were the first internet major event, right?
It was. We had one fellow who was like, we saw these. We were able to put these pictures out, and because there was no science barrier, we could put pictures out almost immediately out in the web. No one had ever done that before. Mm-hmm. But the trouble is we didn't have the infrastructure. So what we did was we called up all these companies that had servers and access and actually got a bunch of links. So when you came to the Pathfinder page, is that you picked which server you wanted to go to see the pictures. That wasn't just, where you get a spinning wheel of death, spinning watch or wheel of death. Yeah. And so you pick that, and that's how we let the public balance out these different servers. So all we had to do is mirror the same data to these multiple sites with different URLs, and it was kind of interesting.
Wow.
That's how we did in the old days. One of your server sites?
Sorry?
Was AOL one of your select server sites?
Could have been. I think there's a whole bunch of them. These are companies that volunteered.
GeoCities, Rod. GeoCities.
Yeah.
Back in 97. So.
All right, you old timers. And by the way, Rob, interestingly, I was looking up some of your bona fides before last night actually, and your web page from, gosh, it must have been the mid 2000s is still up. You still have a bio where you have a shockingly black beard.
Mm-hmm.
And
I don't have any. I don't do my own bio stuff.
Yeah,
online.
I figured. Yeah. It was a NASA thing, so it wasn't you.
It was one of those Mars. I think it was probably one of those Mars.
It was. I think it was Mur.
Yeah.
All right. We're going to go to a break now, and we'll be right back. So don't go anywhere, because from here on out, it's all Rob all the time. Stand by. This episode of This Week in Space is brought to you by Melissa, the data quality experts. For 38 years, Melissa has helped companies harness the value of their customer data to drive insight, maintain data quality, and support global intelligence. All data eventually goes bad, up to 25% per year. Having clean and verified data helps customers to have a smooth, error-free purchase experience. Bad data equals bad business and costs an average of $9 million each year. Flexible to fit any business model, Melissa verifies addresses for more than 240 countries to ensure only valid billing and shipping addresses enter your system. Melissa's international address validation cleans and corrects street addresses worldwide. Chinese, Japanese, and Cyrillic are just a few of the writing systems that Melissa's global address verification supports, and addresses automatically transliterate from one system to another. Focus your spending on where it matters most. Melissa offers free trials and sample codes, flexible pricing, an ROI guarantee, and unlimited technical support to customers all over the world. You can download their free Melissa Lookups app from Google Play or the Apple Store. No sign-up is required. With it, you can validate an address and personal identity in the USA or Canada. You can check global phone numbers to find caller, carrier, and geographical information. And you could check global IP address information and more. Once you're signed up with Melissa, it's easy to integrate their other services. Melissa Identity Verification, You can increase compliance, reduce fraud, and improve onboarding. And Melissa and Rich gain insight into who and where your customers are. Melissa specializes in global intelligence solutions and undergoes independent third-party security audits. They are SOC 2, HIPAA, and GDPR compliant, so you know your data is in the best hands. Make sure your customer data is up to date. Get started today with 1,000 records cleaned for free at melissa.com/twit. That's melissa.com/twit. All right, we're back for the good stuff. So Rob Manning, if I have it right, in your long and storied career, which I've followed since Pathfinder, actually, you've worked on Galileo, Cassini, Magellan, Mars Pathfinder, Mars Exploration Rovers, Curiosity, Mars Phoenix, Mars Reconnaissance Orbiter, Perseverance, a little bit of Voyager, and the Mars Polar Lander and the Mars Climate Orbiter. Did I miss anything?
Probably. LDS.
Yeah.
The LDSD, which is this this parachute test project that was really fun out in Hawaii, where we tore massive parachutes to shreds.
Yeah. So I would love to talk about all these things today, but since we're almost at the halfway point, we're not going to get there, and we're going to have to see if we could pull you back in for a part 2. But before we get into all that, I wanted to read a quote from you that I loved. I don't know how old this is, but I always recommend that you should, this is when you're talking, I think, to younger people. I always recommend you should not worry about career advancement too soon. Spend a decade in your career doing real work, build something, use your hands, good advice, test it, learn from your mistakes, put yourself out there on the edge, which will force your eyes wide open. What made you, what was the motivation for that quote? I love it.
Oh, well, thank you. Well, I think part of it is sort of it's an old person's reactionary comment. First of all, I mean, it's
hey, damn kids off my lawn and build something.
Yeah, get out there. And part of it is that it's so easy to today. It's so much easier. I have to admit, it's wonderful. I'm actually very jealous in some sense of the current generation, what access of information they could get compared to what I was able to get at. You can learn so much. You can learn about system engineering, you can develop, and you can get a sense that you know this stuff in detail from interacting at a high level, and even including doing complicated simulations and things like that. But what you don't often get is a realization of what I call the fractal complexity of some of the things that we create. I mean, even the most simple thing that you think you understand, if you peel the onion deeper and deeper, you find there's more and more richness at a level of granularity that you really didn't think you'd ever want to learn or needed to learn. And so without that, having that experience of deep dive into things and really understanding it and seeing it with your own eyes and in 3D. And by the way, I would even say that's true for software, checking the code, really learning what is going on with a multitasking operating system. How do context switches work? How do service routines work? There's a whole bunch of things, whether it's software or hardware, or system design or navigation, doesn't matter. You need to be able to dive in and see what's really going on. And if you can get that kind of depth, you start appreciating how broad, when you start thinking about a complex thing of making a Mars rover or something, just how massive it really is in terms of complexity at levels all the way down. Now we try to design things so that you don't have to think about those complexities. When we pick up our phones, we text somebody, we just expect all the little machinery inside. How tough can it be? I just text and hit the send button. What's wrong with that? There's no complexity there. But if you would really understand what happens along the way, all the different things, all the different interfaces, all the different hardware, all the different patterns, all the ways how information gets routed, you would be shocked at the incredible complexity that's inside these things. And now, you don't need to know that stuff to be able to use this stuff. But and if everything goes your way, you can do everything without having to think about those details. It's wonderful. But more often than not, just like what's happening right now on the Psyche mission, which is supposed to launch on the 12th, as Malik said, Derek said, we are going to, we discovered that there's more richness and detail at a low level of detail, at lower level of the design than we ever realized. And even despite the fact that people have looked at it on and off over the years, we miss something. And that, so you have to appreciate that those misses are possible, and that you need to be able to let go of your own mental preconceptions, and just dive in and understand it authentically and in detail. It's very tedious, and you can't expect to do that for everything. It's just too hard. But don't be afraid to do that, and don't be daunted by that prospect.
So I just wanted to add a kind of a thought and a question to that, which is, when I was young, I did, tons of Lego, of course, we all did. But back then you didn't have specific kits. You just had pieces and you had to design your own stuff. So the thinking was a little different than it would be with a modern set. And then we had erector sets and all that kind of junk. And then later, a lot of us got into cars and so forth. And what I've noticed with my son and other people his age, so let's say in their 20s, early 30s now, they have a comprehension of the digital world and the interface through which we live much of our lives these days that's completely different from mine, especially when it comes to small screen devices like phones. On the other hand, I find that for myself anyway, my appreciation of things in the physical world is different because I grew up in the electromechanical era primarily. And so when it comes time to figure out something that involves either hand-eye coordination or just mechanical function, I can usually apprehend that in my mind much faster than the younger folks that I work with anyway can. And I wonder, since you mentioned do something with your hands, if that's a part of what you see with younger engineers, because it must be very different for them.
It is. Many of them have had experiences, for example, with CubeSats in developing, putting together systems that actually fly, or electric cars or something. A lot of them had some of that experience, but it's still a little bit closer to. It's still a little abstract. I mean, it's a little bit like Legos. I mean, one of the things about Legos is that it's the resolution of the complexity kind of stops at about a 1 centimeter square cube.
Oh, interesting. Right? Yeah.
And so think about that. There's not a lot going on at lower levels of complexity at that. So it stops, and that's okay. It's amazing what you could build when you stop at that level of resolution, right? So this idea that the system is somehow pixelated or blocked is a very convenient thing for human minds to get around, because we try to simplify our world by blocking things up. We try to create functions, and that's nothing. There's nothing wrong with that. It's in fact, as a good engineer, if you're trying to design something, your mission in life is to try to, whatever thing you're making masks a huge amount of complexity. So what it looks like when you step into an elegant fighter aircraft or a new car, the cockpit feel, everything about you, what you see when you sit down in these cars or in these planes, that is the plane, and everything else. And that's the thing, the complexity that the plane or the automobile presents to you. And that is, what's going on behind the scenes is hidden, and it's supposed to be hidden. Remember the Max, what is it, Max 8? I forget the number for the Boeing.
The 737 Max?
Yeah, 737 Max. Where there was a lot of pilots did not know about how the control system worked and how the airstream indicator was integrated into the system, and how it was used as a performance modification in addition to a fault tolerance system, and how that really worked. And so that was all hidden from them, because they said, don't have to worry your head about this. This is all built into the software. Well, it turns out sometimes you need to know about that stuff. Yeah. And so, it's hard to do that because I know developers for cell phones, they work very hard to hide an enormous amount of detail from all of us, because if we did, our heads would explode. Seriously, I mean, there's just so much detail, and it's not because they're being malicious or obscure. There's a good word. They're not trying to obscure the system from you, but just really trying to make it easy for you to use. And so your brain doesn't have to engage many neurons in your busy day to deal with this kind of stuff. And that simplification is great, but it also, you can't use it to say that is all there is. But because there's so much more, much more.
No, that's amazing. You know, I can say, Rob, as someone who is not technically inclined, who just built a computer for the first time, just putting the pieces together and understanding what pieces you need, opened my eyes to just that one part of technology that we all take for granted. And that's just that's not even putting robots on Mars, or
not
driving them
hardly,
around.
my friend.
Not at all.
I built a computer. Woo!
No, I wanted to point out really quick, just because Rob mentioned it for Psyche, that they're learning new things, that there was a delay. It was going to launch on the 5th. Now it's launching on the 12th to go through some final checks on thrusters and stuff. And it's always good to do those checks now before it gets into space and causes an issue. And so we've seen that a lot in the past.
I'm sure our chief engineer
if people were wondering
that advice.
No. But for the listener who maybe didn't know that it was delayed, because it happened at 7:30 last night, it was announced. That's kind of the backdrop for the Psyche discussion there. I wanted just to ask, and forgive me if it's a long story, but how you become chief engineer at the NASA's Jet Propulsion Laboratory. Was space something that was always in your sights as a kid growing up, or was it something that you fell into as part of your education or your path going just like a natural evolution?
Eric, that's a great question. It turns out a little of both. I think, well, there's no doubt from a very early on, I was mesmerized by space. I loved it. But in those days, the sources of information were so narrow. Most of my understanding of space was what I conjured in my imagination, because my sources were included like National Geographic magazine, Time Life magazine, the newspapers, Popular Mechanics,
Boys Life.
Boys Life actually did, but they hardly ever published details. It was kind of lame, I shouldn't say that. It was not very rich. So I really found that that was my source. But I was growing up, I was very much aware of John Glenn's first flight, and then the subsequent Gemini program. I bought Marvel models and built a Gemini spacecraft and painted it with incredible details, and try to deduce what all these different things, bumpy things were sticking on the vehicle, what they were for. I never did until later in life. But it was something that really was drawn to me. But I never thought that in my wildest dream would I ever do this, be able to actually succeed at doing this. And so it's come as a major surprise in my life that I made it to this spot. I'm shocked. Especially since because I had a very modest beginnings. I worked my way up through first science, math, physics, and electrical engineering, and then struggling for a job. I started working for JPL initially as a technician and a draftsman. One of my first jobs at JPL was making sure the humidifier was filled with water and that the ashtrays were empty, because we had ashtrays everywhere. So, I mean, this is the kind of thing. So,
that's an environmental hazard.
That's one of the things that I did. I did that other stuff, like, making sure that people are using the right yellow and red pencils to redline electrical circuit net lists on these old fashioned, big old printouts with all the holes on them. And, that came out of these line printers in the old days. And so we would redline that. That was how we did information control, was with printouts and colored pencils, because we didn't have laptops or computers or anything. Everything was done by hand. So I grew up in the build it by hand with white blackboards and paper and pencils. And drafting paper, and using number 2 pencils and vellum drawings and spinning erasers. That was my world. And I started with that and worked my way up over time doing more and more things that I found I was curious about. And because JPL is such a big place, really, I could move from one organization after spending a small number of years in an organization, get good at this. I was able to move laterally to adjacent organizations, and it worked in that area, and then worked another adjacent, and worked my way up, sprodding myself up to the point where I knew enough about, in this case, all the electronics systems that are on board a spacecraft, the power, the computing systems, the software, how it all worked from an electronic systems perspective. Avionics, we called it, and we call it still today. And then eventually worked my way onto systems. And then I had to discover something like entry, descent, landing, and parachutes, and entry dynamics, and hypersonic travel, and aerothermal heating, and things of that sort. So in Mars Pathfinder, so I really super broadened myself out in that direction, far away from electronics. But I was able to glue the electronic systems with all the things to make the entry, descent, landing work. And because of that kind of led me to another higher levels of systems engineering, and eventually applying the same techniques for building rovers and systems from that. And that's how I got in there. And I tell you, and all my career passes, I never lobbied for a job. I just said, if you want, I'll be happy to do that if you want. And it just happened. And so it's kind of part of it. No, it's not because of talent too. A lot of this is, I can tell people, luck plays a huge role. Being at the right place at the right time is actually a key factor. So many people tell us, well, I got this spark because I was talented, I worked hard, unlike all these other people. And I go no, you just happen to be lucky sometimes, because there's some other wonderful people all around you who just weren't standing in that spot on that day, at that moment, to get that situation set up. So I want people to remember that sometimes you have to create your luck, making sure you're staying at the right point at the right time, if that's something that you care about, or just making sure you're available, and that people know you, and that you and people are comfortable around you. That's another important factor.
Mm. All right. Well, we're going to be back with my next burning question right after the short break, so go nowhere. This episode of This Week in Space is brought to you by our friends at IT Pro TV, now ACI Learning. Our listeners know the name IT Pro TV is one of our trusted sponsors for the last decade. As part of ACI Learning, IT Pro TV, now IT Pro, has elevated their highly entertaining, bingeable short format content with over 7,200 hours to choose from, with new episodes added daily. ACI Learning's personal account managers will be with you every step of the way. Fortify your expertise with access to self-paced IT training videos, interactive practice labs, and certification practice tests. One user shared, "This is an excellent resource, not just for theory, but for labs incorporated within the subscription. It's fantastic. Highly recommend the resource and top-class instructors." Don't miss ACI Learning's practice labs, where you can test and experiment before deploying new apps or updates without compromising your live system. MSPs love it. You can retake practice IT certification tests so you're confident when you sit for the actual exam. ACI Learning brings you IT practice exam questions from Microsoft, CompTIA, EC Council, PMI, and many more. You can access every vendor and skill you need to advance your IT career in one place. ACI Learning is the only official video training for CompTIA. Or check out their Microsoft IT training, Cisco training, Linux training, Apple training, security, cloud, and more. Learn IT, pass your certs, and get your dream job. Or if you're ready to bring your group along, head over to our special link and fill out the form for your team. TWIT listeners receive at least 20% off an IT Pro Enterprise solution and can reach up to 65% off for volume discounts depending on the number of seats you need. Learn more about ACI Learning's premium training options across audit, IT, and cybersecurity readiness at go.acilearning.com/twit. For individuals, use code TWIT30 for 30% off a standard or premium individual IT Pro membership. That's go.acilearning.com/twit. Let's not forget the role of tenacity and ability, however, because you exhibited both those properties as well. I mean, a lot of people, when you were getting started at JPL, I was getting started in television. And they told us, you just work hard and you'll get noticed and rise to the top. And I was working in television commercials, and it turned out it was a lot more important to have good cocaine connections than it was to just be a hard worker. And I don't mean to sound jaded. I mean, that was really a thing in the 80s.
Yeah.
And if you weren't part of the drug culture, you were going to fall behind. And that, that was okay. I mean, that was the business I chose.
It was.
But, you have exhibited an awful lot of ability, which brings me to my next question. And I hope you're not sick to death of talking about this, because I drag you into this every time we get together. But moving from that point at which you left us in your description of your job, you embarked on this project. I think it was your first chief engineer stint was with Mars Pathfinder, correct?
Correct.
So this is the first time we'd gone back to Mars since the Viking landers, at least to the surface of Mars.
Yeah.
So, high risk mission, a lot of uncertainty, and yet it kind of felt like there was this perfect storm going on. You were a little off, if not off the radar, at least not under the microscopic focus of headquarters. And at least watching the videos of your time in that program and interviewing you about it for a couple of books, it sounds like it was really kind of a magical time and something that probably won't happen again.
It is hard to recreate that. You're absolutely right. It was really a small group of people given permission to, and I like that. See that old painting. I love that painting.
Yeah.
We were sort of given permission to do a faster, better, cheaper mission under the radar. NASA had really not adopted a lot of rules on how to do that. They basically said, do whatever you think it makes sense. We had a very small team of people. Some people were very experienced. We had, like, our mission assurance manager was actually a key mission assurance manager on the Apollo program. So you would think that they were very, very conservative, but no, they were like, well, we'll just make sure we do the right thing. Make sure we think about things. And so we were given a lot of a carte blanche. Our whole team was in a building which, unlike all the other buildings, had like card key access, and the rest of our employees of JPL, if you weren't on the team, had to be escorted in. So it was like we were kind of like really isolated. There's no windows. It was the second floor of Building 230, right above. If you've ever been to JPL, there's a dark room. You can overlook the Deep Space Network operations, since the center of the universe for communications with our spacecraft. Right above that whole floor was just us. It had been used by the Magellan mission, and so we were basically given, and we were told, by the way, okay, your mission, did you choose to accept it? And we said, of course. Is build a lander that lands on Mars. If you want to take pictures, you can. Maybe take a couple of pictures, and then send this little rover off and drive a little bit on Mars. And you can last a couple of weeks to a month, and then you can be over. So what about our science objective? There's no science objectives. You're just proving we can do it cheap, because we're not going to give you much money. And so whereas the Viking program in those years, dollars, was over $3 billion, of course, 2 landers and 2 orbiters, that's, that does count. Our mission was given altogether to develop the mission. We were given about $150 million, which, to a normal human being, I can do a lot with $150 million myself. But if you look at today, how much things cost today, that is astoundingly low cost. Mm-hmm. Especially to go all the way across the solar system and then land and then drive, that was considered a taller. And of course, it was all sort of kludgy. It looked like, we weren't landing like a normal lander was supposed to land, with engines lowering itself down on legs. Instead, we're doing these airbags and parachutes and rockets. What the heck? And the reason we were doing all those things is because we didn't have the money to do anything else. Mm-hmm. It was the engines were the throttled engines we had for Viking 20 years earlier had also been ceased to been developed. No one worked on throttled engines anymore. They're all pulse mode engines, but those pulse mode engines weren't designed for landing. So we were struggling to come up with an architecture that didn't need them. And so our mechanical engineers said, well, what if we there's a descent set for landing cargo on the surface of the Earth, like a big old tank under a parachute. Just like this, Soyuz, you fire rockets just in the last instant to stop its speed. In the case of this, it's called Lars, I forget, system that the Army developed years ago. There were some rockets between the payload and the parachute, and the rockets were kind of on the cable. And when they fired, they stopped. They're kind of canted out so you don't cook cook your tank. They were fired just in the last seconds before touchdown to lower this descent velocity so it didn't hit the ground too fast under the parachute. And this is, of course, the sky crane thing you're looking at here. But back in those days, we used our descent engines on the not in the back shell, but in the parachute, on the back shell along the parachute line, and that slowed us down before we can cut the airbags free. And the whole idea was eventually we decided to bring it to a stop in midair, some 15 to 20 meters above the ground, and cut the cable, and then the airbag bounced on the surface. That was the idea.
Yeah. And I think for Ant, line 42, there's like a 50-year Mars exploration video that I found, and there's a nice little clip of the animation for the Pathfinder landing. We should actually point out, because Rob, that was a great description of finding that novel way to land on Mars, but there might be folks that are listening that don't know what Pathfinder is. So just a really quick reminder, because I remember exactly where I was during landing. But Pathfinder was this small, comparatively, a lander and a rover combo that launched in December of 96, and it landed on the 4th of July in 1997. I was driving to San Francisco, listening to it blow by blow on the radio at that point in time from Stockton, and it was like this whole brand new way of landing. You had this airbag landing. It landed and it tumbled, and then the airbags deflated, and then it opened like a flower with these petals, and then we saw Ant was showing the video of the landing site in Ares Vallis on Mars, where it had like the little rover was about the size of a big shoebox, 23 pounds, and Sojourner in it. And it just drove out there and had a little camera, had a little sensor arm thing, and like touched the Yogi Rock, and we were all so excited. And now you have nuclear powered cars on Mars, Rob. But it was the first rover, right? It was the first rover on Mars ever, and it was revolutionary at that point in time. And they shot fireworks off the Capitol building in Sacramento for the landing. So
it was amazing. And we were, it's funny. We had a choice of landing around that date. And my friend Richard Cook says, so why don't we just do it on the 4th of July? Okay. We just aimed for that. I was like, okay. So that means we no picnics. We're going to be working. Oh, that's okay. We're working anyway.
How decisions are really made.
Yeah, exactly. So we it was really the only options were roughly around then, given the dynamics of what we were trying to do. It was a pretty fast entry. We had a 7.6 kilometer per second entry. It's still the fastest entry of any of our vehicles at Mars so far. But it's never been done. It never had a direct entry, because the two Viking missions first put themselves into orbit around Mars before separating from their orbiters and then doing a descent directly from orbit, which at quite a bit slower speeds. So and
we should add they had months to do a lot of hand wringing, and worrying and imaging, and that looks like this, and then you had to go straight in like a bullet from a hunting rifle.
They were trying to also land the 4th of July, it turns out, in 1976. But when they got there and took some pictures of where they thought they were going to land, they looked like, oh, yeah. That's not good. We can't go there. And the thing is, their resolution of their camera even then was not so great. And so they couldn't see like even, 1 or 2 meter boulders. They just were all blurry at that scale. So, but what they did was but there were so many other things. Mars, it turned out, surprised the heck out of everybody just how rough and rugged it is. Mars, there's not that many places which are really smooth. And the reason we see so many pictures that are smooth is because we intentionally went there. Because the other parts are so scary. I would still love to eventually land something like a small rover in Aris Vallis. The Melis Chasma in particular, my favorite spot. It's a nice spot if you come in. When you do there's a video of our landing there, and we landed at night too, which is fun, which is cool. Laying at night, and this picture show us bouncing. Our actual bounce was much higher than that by mistake. I won't tell you why. I goofed. It rolls to a stop. It rolled we collected data for 1 minute. I thought that was plenty. Turns out we were still rocking and rolling after a minute. So we stopped collecting data after 60 seconds, and we probably got another 60 seconds of bouncing. And there's us. This is actually the same control room where we now operate the spirit. I mean, Curiosity. And it's Mars 2020. The same floor, right above the dark room there. Anyway, so our it was nice landing at night because there's no winds, less winds early in the morning. And this is susceptible to winds because if the parachute pushes off to one side, the rockets are coming at an angle, and they will actually, even though they slow your descent rate, but also cause you to accelerate horizontally. So the airbags would have to land at a grazing angle. Very irritating, and because airbags don't like that.
Yeah.
And
as it turns out,
and what's more, as soon as we landed and opened up like a flower, as you said, Derek. And dragged the airbags in, and the sun came, Earth rose, and then the sun came up, and we're very quickly to be able to do the missions. Now, in order to keep, both for the visual reasons and to keep radio communication, we land in the late afternoon on Mars, which is very irritating because when you land, the first thing you have to shut everything off to save power, to keep your battery from draining, because you've used up so much of your electricity to land. And then, and basically the whole vehicle shuts off. It's like, well, how'd it go? I think it worked. Yeah, it worked okay. We just got a little bit of information saying it's all worked. So it's thumbs up. Okay, now it's asleep. Okay, we have to wait till morning to start again. Bummer. And so anyway, there's some fun features about Pathfinder, which were nice that we don't do anymore. But we use the same airbag landing technology, same tetrahedron architecture, the same EDL architecture, the same cruise stage and same entry vehicle shape and everything else. To land Spirit and Opportunity a few years later.
Mm-hmm. And they were, of course, much bigger. And Pathfinder,
it's the same size.
That's right. So
they were the same size. Most people don't think Pathfinder was littler, but Pathfinder, what we did was that whole lander structure. It was heavier. We stuffed more stuff inside the same tetrahedron.
Yeah.
But which was trouble for the airbags. So we had to add more complexity, like other rockets and cameras that look to the ground and try to be smart about landing, but it's amazing that it all fit in there. So we basically took the Pathfinder structure and just put the white box inside with the JPL letter on it. We put wheels on it and sent it to Mars.
And we're looking at Viking now, so that's
there's Viking. There's
a couple of decades off, but
that's Gentry. You recognize him.
We got to go to one more break, and then I want to come back. I think we're going to have to come back and wrap up Pathfinder and save the other 20 or so mission questions that I have for you until we can get you again. But bear with us. We'll be right back. Don't go away. Okay, so I can't tell you how many questions I've got just on Pathfinder, but I guess would you mind going into a little more detail about, and again, this is stuff I just learned from you because we talked about it for the Mars book we did together, but the vibe when you were working on this mission, the Pathfinder mission, was pretty informal.
Oh yeah.
You did a lot of ad hoc engineering, we need sand to simulate Mars. I'll run down and buy some at the playground store. I mean, this is not how we think of NASA doing business.
That's correct. Yeah. It was kind of interesting. It was actually bifurcated in the sense the team that we did, we were very much low budget. For example, to lay out the prop system, in the old days we had people had early, still had reasonably good Macs with MacDraw, and we would do a drawing of the layout of the prop system in MacDraw, and to print out 8.5 by 11 sheets of paper with that to full scale. And what we did is I took a big sheet of plywood and then stapled all these 8.5, 11 sheets of paper on the plywood, and that became the layout template for the propulsion system. That's the kind of thing that we would do. That's to save money. On the other hand, the overall arc of how we were going to prove this was going to work really needed to be, that story needed to be told. And headquarters was very nervous about this faster, better, cheaper thing. And the general impression was the probability of this thing working was very low. And that was communicated that way to everybody because of all this cheap things that we were doing like that. We bought a radar, a descent to detect our altitude, and we used that to infer our velocity. It was a $13,000 radar. That sounds like a lot of money today, but for a space avionics radar, those are usually millions of dollars. Right. $13,000, and so we go, that's actually cheap. We need to test the heck out of it. Maybe we should get some more of them. So we bought 10 of them. And dropped them out of parachutes, and because we were testing. So we were afraid we were going to break them. Of course, we did when we did our testing, but eventually got to know it inside and out, and use that for our system. So we did stuff like that. However, the other side is the anxiety. So NASA and our project manager Tony Spear worked we need to find the most top technical people in NASA who are the most critical, could be the most critical people for this project, and critique this team and what their work is. And if this team doesn't pass muster with this community of top technical experts and experienced people, we're not flying it. Oh, and by the way, your $150 million, if you go one penny over that, we're canceling it.
And this was on the JPL side, this is being said.
It was, and NASA. It was both. Okay. It was both. They were all saying, they're all convinced that we needed to be reviewed by the heavyweights. So we had our review board was some of the most exquisitely intelligent and intense big people you would ever want to meet. We had the chief, the project manager for Viking. We had the chief engineer, Jim Martin. We had the chief engineer for Viking, Is Tabak. We had none other than Mike Griffin with all his PhDs marching in. We had Gentry Lee, who wasn't working at JPL back then. He was still writing books in Texas. We had many other people, including people like Max Faget from Apollo days, C.C. Caldwell Johnson, who helped design the Apollo landing architecture and the many other parts of the vehicle, the whole much of the architecture comes from his fingertips and his pen. And we had all these top people, John Cassani, others, a JPL legend. These people who just and their view, we've got nothing to lose here by telling these guys they're idiots. And so they basically, when we said something stupid, boy, they pointed it out, and we kind of liked that. I was a mid-career person at the time, but many of our team members were much younger. There's a few people, very strong people who've been around for a long time, like Tony, and a few others. But their view is we're nothing. If we're not doing it right, we shouldn't do it. And so that's actually a really good open-minded way of thinking about it. To be honest with you, we were terrified, and we were more actually. What happened? We got super terrified about what kind of responsibilities we had. We did a field trip to Washington State. It turns out we were landing at Aris Vallis, a part of Mars that was part of a catastrophic outflow channel billions of years ago, when there was a massive cascade of water due to events that I don't know if have been explained or not. But so we went to a place where there had been a catastrophic outflow channel, and that was in the scablands of eastern Washington State. So we flew up there, brought in models, looked at the site, trying to figure out what how to deal with the kind of the rocks and airbags and rover deployment and things like that. And on the way, they brought the science team was with us, and they brought with them a bunch of teachers as part of the outreach program. So they came along on bus rides and airplane rides. We flew over and looked at it. And then what happened was one rainy day in Spokane, we all got together and we just put a little notice in the Spokane paper that we were going to come and Mars people are going to talk. And in the middle of this rainy day, this little high school that we stopped by, our junior high, just inundated with people who came out in the rain to hear what a bunch of Mars engineers and scientists had to say. And suddenly we realized that it wasn't just us doing this. This was the whole world is going to be watching us, and everybody cared. It had been 20 years since the last Mars mission. Mars had disappeared off the public's radar, and suddenly we were putting it back on. And suddenly the responsibility was like really real. So when these review boards came along and told us we were idiots, we listened. And in fact, not once, but twice we had major reviews where we flunked the review and we were told to come back again in 3 weeks and tell us the right story this time.
Wow.
Well, what's the right story?
Well, I think the proof is in the pudding, right? I mean, you were set for a 1 month mission on the surface of Mars. Pathfinder lasted 3 months.
Correct.
Mars exploration lander Spirit and Opportunity lasted years.
Yeah.
Right.
Sorry.
and Curiosity's still going almost a decade plus now. And so, I mean, I'm curious, I guess, and this is probably our last question. I apologize. But it seems like that experience that you've just outlined set the stage for exceeding expectations on these types of missions with the approach, the engineering approach,
right,
and mindset that you and your team outlined for these types of missions. And I'm just wondering if that was ever surprising to you to know that it would last, that Pathfinder lasted that long, that the other missions would far exceed their lifetimes and yield so much more about the planets and these asteroids, these planets that we've seen.
Well, absolutely. We're shocked. I mean, this is, listen, so when people told me, it's like, Rob, you failed as an engineer because you were given money by the taxpayer to do this job for this length. And yet you over designed it. You spent more taxpayers' money than you should have to make it. And it went that much further. What were you thinking? Why don't you just tie up what if you'd done it right, it would have died on Sol 90. And I go and I'm like, okay, the only way I know how to make a rover die on Sol 90 is to put a ticking time bomb on it. And so the thing is, the trouble is we put margin in our design, elbow room in our design, but that elbow room is there to help us with our own mental shortcomings, our own inability to foresee the future, understand the systems we're building. That complexity I talked about at the beginning, it's real, and we need to put that elbow room in, and we don't know when that's going to pay off or when it's going to just save our bacon and make us to Sol 89, let alone 90. And that's true. So in the case of Spirit and Opportunity, we really didn't think we could survive. In fact, we never even analyzed a situation where we'd have to survive the winter and do like deep sleeps. No, we never designed for deep sleep.
Much less 14 times.
That's right.
Yeah, and exactly. And
not 14.7.
Yeah, lots of stretching things out. And of course, we thought we were saved, of course, by I like to joke Mars monkeys with squeegees and Windex cleaning their solar panels in the middle of the night. It was wind events that actually came along that actually cleaned passing wind storms. I'm skeptical of dust devils because they go past so fast and they don't really do much. But these strong wind events, which with entrained dust that basically sandblast the dust off, causing that suddenly that we have enough power to last forever. And like, wow, what happened? So we try not to over design our systems, but we don't know when we're doing it too much or too little. We try to put it just enough. In fact, at JPL, we have something called design principles, which specify how much margin you need to put in your design. And we don't ask people to put a lot more than that. Mm-hmm. Sometimes it pays off. Sometimes it doesn't.
Well, you really are daring mighty things over at JPL there. So.
Thank you.
Oh, what a nice wrap up. as I think I mentioned, I've got another about 21 questions that I don't think we're going to get to because we're at our hour. So I'll contact Dolores and see if maybe we can get you for another session.
Sure, I would love to. It's fun. I love doing this. Because
you could eventually repackage these as the Manning lectures, kind of like the Feynman lectures, and they can become the masterclass for junior engineers because you make it fun. And we really would like to stay with this fun for a little longer, but we have to move along. But besides saying thank you for joining us today, I'd like you to let us know where we can best track your upcoming adventures.
Where I can tell you
besides the new website. I mean,
I check the website. I think JPL's, NASA's got some new improved website. There's a lot of great things at JPL. The things, there's just so many things of discovery. We've got these wonderful missions. The SWAT spacecraft we put into orbit around Earth that's looking for the distribution of water on this planet. It's not Mars. We already know there's water here, but now we need to analytically understand exactly where that water is moving, how it's changing as the Earth is changing. And so
that's the oceanic
correct
observer.
That's right. It's looking and water and waterways and rivers and we have another mission that's coming up, launching soon, called NISAR, which is a radar working with the Indian Space Agency, ISRO, where we're going to partner to go through over Earth and also very carefully measure the water and the distribution of water heights and changing weather patterns on the surface, especially as the ice melts at the poles. And so we've got a lot of hope that we'll be able to use this information to make better decisions about how we manage our planet. And of course, we have also under construction, we have the Europa Clipper orbiter, which is going to be orbiting around Jupiter and swinging by Europa about 40 times in a few years' time. It will be launched in a year from now. It's massively complex. It's going to a place, I tell you, if anyone says, hey, I got you free tickets to go into orbit around Jupiter, say no. There's a big do not enter sign on Jupiter. It's a very dangerous place to go with radiation effects. So making a spacecraft that can handle swinging by that close through its magnetic field and its radiation belt was very difficult and painful and expensive. But we've got it. We think it's going to work, and it's going to be an amazing mission. We'll find out. It's just like we learned recently with, if you heard that just recently, the JWST space telescope took image of Europa and saw far more carbon on the surface than we expected. And so this mission will really help confirm that and understand its distribution on the surface. Even more detailed than just the area that was discovered here recently. So hopefully we'll discover that Europa is actually a place that actually might harbor prebiotic life.
That'd be exciting.
Or early biotic life, yeah.
Right. And Tarek, which presidential debate will be seeing you on?
Well, I was just thinking, they found all that carbon at Europa. I'm made of carbon. You're made of carbon. We're all made of carbon. So that sounds exciting. No, you can find me on thespace.com. As always, this weekend, if you're in New York, I'll be at Toy Fair looking at all the awesome new rockets and telescopes that are going to be coming out for kids, and get ready. And also at space.com as we get ready for the missions to come. I'll be looking at the solar eclipse coming up. We'll talk about it next week, maybe too, a little bit in news on October 14th, and on the Twitter at Tarek J. Malik. You can find me there too.
And just one thing, don't forget that on the 12th, we heard Psyche is going to be launching. Wish us luck. And this is exciting mission to go explore the Psyche asteroid, and to see whether or not it's actually the remnants of an early planetoid, and we think it's an all metal piece of rock that might just be the center of an old planet, a mini planet.
We were good. We had Lindy on a couple of weeks ago. And
wonderful. She's fabulous.
Sensational. Yeah, she's. Yeah.
I was just going to say that if a mission to an all metal asteroid like protoplanetoid doesn't get you, it's also launching on a Falcon Heavy rocket, which is the biggest most powerful operational rocket right now. So there's that too. So
yeah, exciting.
Okay, should I leave you guys alone for a while? So you can geek out about this stuff. All right. And of course, you can always find me at pilebooks.com and at astromagazine.com. Please don't forget, you can drop us a line anytime at twit.tv. That's TWIS at twit.tv. We welcome your comments, suggestions, feedback, insults, whatever you got. And we do answer each and every email. Also, don't forget to check out space.com. The website's in the name, and the National Space Society at nss.org. Both are good places to satisfy your spaceflight cravings, almost as good as the Jet Propulsion Laboratory website, which will be on the show notes, jpl.nasa.org. New episodes of this podcast published every Friday on your favorite podcatcher, so make sure to subscribe, tell your friends, give us reviews. We'll take whatever you got. And you can always head to our website at twit.tv/TWIS. Don't forget, you can get all the great programming on the Twit network ad-free on Club Twit, as well as some extras. We're not going to tell you what they are. They're secrets. Only available there for $7 a month, and you can follow the Twit Tech Podcast Network at Twit on Twitter and on Facebook and twit.tv on Instagram. Thanks, everybody. Thank you, Rob. Thank you, Tarek. See you next time.
Come join us on This Week in Enterprise Tech. Expert co-host and I talk about the enterprise world, and we're joined by industry professionals and trailblazers like CEOs, CIOs, CTOs, CISOs, every acronym role, plus IT pros and marketeers. And we talk about technology, software plus services, security, you name it, everything under the sun. You know what? I learn something each and every week, and I bet you will too. So definitely join us. And of course, check out the twit.tv website and click on This Week in Enterprise Tech to subscribe today.